Hello, my name is KAAN ÖNDER. I'm a first year electrical and electronics engineering student at Bilkent University. I'm at Physics 101 Section 3. This is my physics lab experiment. We'll be calculating spring constants using the conservation of mechanical energy.
In this experiment, we will be using the conservation of mechanical energy by calculating the kinetic energy of a weight with a non-zero velocity and the maximum distance that weight can compress in a spring. We will do this by assuming that on the instance the spring compression is at maximum, all kinetic energy is converted into spring potential energy. By using the equation 1/2 kx squared equals 1/2 mv squared, where k is the spring constant of the spring, x is the distance of the spring compressed, m is the mass of the thrown object, and v is the velocity of the object, we will be computing the constant k by experimentally measuring all other variables. For this experiment, we'll use a spring, weights to repeat the experiment with different masses, a ruler to measure the compression distance, an air table to minimize friction, and a spark timer to compute velocity, as well as a wooden block and double-sided tape for more stability. The experiment will be made in the manner of gently sliding a weight that has been pre-measured towards a spring on top of an air table, while a spark timer is being used to calculate velocity. After the weight bounces back via the recorded video, the maximum compression will be measured, and using these three values, k will be calculated. This will be repeated 4 times, all with different masses. In 4 recorded trials, I found k to be the following, in order: 416.6, 438.9, 414.9, 471.4, and in average 434.5. Even though theoretically k is independent of mass and all 4 trials should have resulted in the same value, a margin of error was inescapably in the recorded values. Due to the values showing no particular trend with respect to mass, I would speculate this is simply a factor of random error, likely caused by imperfect throws of the weight, imperfect measuring, friction, and a slew of other environmental factors. Conclusions to be drawn from this experiment are as follows. While it is possible to roughly calculate a spring constant with the proposed method and observe the conservation of mechanical energy, sources of error previously discussed will likely distort it with considerable factor, to the point that spring constant calculations with this method are considerably imprecise.